All right, guys, we're going to continue with Chapter 1, Section 1.3, and we're going to be describing quantitative data with numbers now. So we looked at the different types of graphs that we could use for quantitative data, and now we're going to be looking at the different types of ways we can describe quantitative data kind of numerically speaking. So the most common measure of center is the ordinary mean, all right? I'm sure you all know about the mean. So to find the mean, which we're going to refer to as x bar, we call it x bar. It sounds just like that, x with a bar on top. We just add up the values and divide by the number of observations. I know all of you already know that. So we know that x bar is equal to the sum of the observations, aka add up all your values, and then divided by n, which is the total number of observations. All right? In mathematics, what you're going to see is that Greek letter sigma, which some of you might already know, which just means sum or add them all up. So on the fancy statistics formula sheet, which you're all going to get, you'll see a formula for finding the mean, which is on the formula sheet. X bar equals sigma x sub I over n. So all you need to know, sigma represents sum. And you all know about the mean already. Another common measure of center, and these are measures of center that we're discussing here, is the median. And I'm sure most, if not all of you already know, that the median describes the midpoint, or the middle value in a distribution. Okay, so we have mean, which is our average, and then we have the median, which is our middle value. The median, like we said, is the midpoint of a distribution. And so it's the number such that half of the observations are smaller and half are larger. Now sometimes we have an even number, which we're going to talk about. Again, most of you already know all of this, so if you do, feel free to skip ahead. So to find the median, make sure that you arrange all the observations from smallest to largest. If the number of observation is odd, then the median is just the center observation, or that middle observation in the list. If the number of observations is even, then the median is the average of the two center observations in the ordered list. So if we have an even number of values, if n is even, then we'll have to take the average of those two middle numbers to find the median. We'll go through this example in class. One thing I do want you to write down here is how to find this stuff on the calculator. So on the calculator, and if you want to do this ahead of time, feel free. Step one, you're going to enter your data in. Well, where do you enter your data? Stat edit. After that, you're going to enter it into L1, and then you're going to go to stat and calc, and then one var stats, which stands for one variable statistics. And that'll get you the mean, the median, standard deviation, as well as a bunch of other things. When you're dealing with measures of, or describing a data set, we have the measures of center, which are the most common things to use, and then we have our measures of spread as well that we also want to use to describe a data set. Measures of center alone can be misleading, okay? So it's important that you don't just talk about the measures of center, and we saw that in our SOCs or SOC V. One of the other things we want to talk about is measures of spread or variability. One such measure of spread, which we're going to see frequently, is the range, which is your max minus your min. We're also going to talk about the interquartile range as well as standard deviation. So one thing we can talk about is the quartiles. So here's how to calculate your quartiles as well as the interquartile range, which is the IQR. Interquartile range measures the range of the middle half of the data. So first we want to arrange the observations in increasing order and locate the median. The first quartile, or Q1, is the median of the observations located to the left of the median in the ordered list. So it's the median of the first half of the data. Your third quartile, same idea, but it's the median of the second half of the data. So it could be like your lower median and your upper median if you want to think of it that way. Interquartile range is defined as the range of the middle half of the data. Q1 is really your 25th percentile, okay, which we'll see more in chapter 2. And Q3 is your 75th percentile. So the IQR is the range of the middle half of the data. And in order to calculate the IQR, it's just Q3 minus Q1. So it is a single number, okay? Q3 minus Q1. We'll go through this example in class on finding and interpreting the IQR. In addition to serving as a measure of spread, the interquartile range is also used as a part of a rule of thumb for identifying outliers. Okay, one of the other things we want to discuss in SOX or SOC V is the outlier. So we have to calculate and show our work when we're discussing outliers. All right? So any value below or less than Q1 minus 1.5 times the interquartile range is an outlier, okay? And any value above or greater than Q3 plus 1.5 times the interquartile range is an outlier. We can think of this as our lower fence and this as our upper fence. So anything outside of the fences is considered an outlier. We'll go through the example in class to determine if there are any outliers in the New York commuter data set. Final thing as a part of this video is dealing with the 5-number summary. So your 5-number summary includes 5 numbers that tell us a lot about the data set. The min and the max tell us little about the distribution as a whole. Those are just our 2 extreme values. Likewise, and the median and the quartiles don't really tell us what's happening at the extremes. So to get a quick summary of both the center and the spread, we combine all 5 numbers to get what we call our 5-number summary. So your 5-number summary is your min, your Q1, your median, your Q3, and your maximum. Okay, which is what we're going to see down below. The 5-number summary, like we just said, consists of those 5 values. One way that we can use to describe a 5-number summary is a box plot, which I'm sure many of you have seen before, a box and whisker plot. Okay, same thing. So how do you make a box plot? Step 1, you're going to draw a central box from your Q1 value to your 3rd quartile. Then, once you've drawn your central box, you're going to draw a line in the box that marks the median. Okay, step 1 might be to actually draw a scale. Okay, draw a number line and scale that number line. Lines called the whiskers extend, and this is crucial, from the box out to the smallest and largest observations that are not outliers. So for example, say we have a data set that looks like 0, 1, 1, 3, 5, 6, 47. And this 47 is obviously an outlier. When we draw in our whisker is going to go to this value here, the next highest value that is not an outlier. Okay? Outliers are going to be marked with a special symbol such as an asterisk. Okay? We're going to compare the distributions of the McDonald's beef and fish sandwiches in class, so you don't have to worry about that, as well as answer the questions that follow. So make sure you have all this down. If you want to try and answer these questions ahead of time, feel free, but we'll go through the rest of this part of the notes in class. See you guys.